Hello everyone. In this video we're going to be solving a differential equation. We have x times y prime plus 2y equals x cubed, and we're going to be solving for y. Y is a function of x in this case, and that's what we're trying to solve for. Now, this differential equation, as far as I can see, is not separable. So we're going to use a really nice trick for this problem. That's why I like this problem, because we use a trick. This is what we're going to do. We're going to be multiplying both sides by something. Now, before you do that, take a look at this expression. We have x times y prime, which could look like the differential of a product, right? Or the derivative of a product, sort of, because we have the function and times the derivative of something else. But the 2y doesn't really fit that pattern. So in order to make it fit that pattern, here's what we're going to do. We're going to multiply both sides by x. So that's my goal. And of course, in this case, I don't want x to be 0. At the end, you're going to notice that x equals 0 actually causes some trouble as well. Okay, so let's go ahead and multiply everything by x. That gives us x squared y prime plus 2xy equals x to the 4th power. Now, here's what I'd like you to notice. I'd like you to notice that we have a product x squared multiplied by y prime, and we have a product 2x multiplied by y. Since the derivative of x squared is 2x, I can just write the y prime as dy over dx, and I can write the 2x as the derivative of x squared. So, and that should be a plus sign, not an equal sign there. And that equals x to the 4th power. Now, notice that we have x squared in one of the products and the derivative of x squared in the other. And we have the y in here, and we have the derivative of y in there. So that kind of fits the pattern of the product rule. So if you think about the product rule, the derivative of the product of two functions like u times v is the derivative of the first function times the second function plus the derivative of the second function times the first function. So we kind of have that pattern here. In other words, this expression can be written as the derivative of x squared times y. Let's go ahead and double check to make sure that we got it right. If you think about this, if you differentiate x squared y, you're going to get the derivative of x squared, which is 2x multiplied by the second function, which is y, plus the derivative of y, which is y prime, multiplied by x squared, and that's exactly what we have. Great. So this is true on the left-hand side, and of course on the right-hand side it is equal to x to the 4th power. So from this we are going to be solving for y, but let's go ahead and multiply both sides by dx. That gives us d of x squared y equals x to the 4th dx. So we have differentials on both sides. That's good because we are about to integrate. Let's go ahead and integrate both sides, because as you know, if you have two differentials that are equal, that's kind of cool, because that means that you were able to separate some stuff. So let's go ahead and integrate both sides with respect to x, obviously. Since y is a function of x, x squared y is a function of x, so d of function of x is something times dx. So that means both sides are integrated with respect to x. So now, as you know from the rules of integration, or you should, when you have the integral of d of something, it is equivalent to the same function. So the left-hand side just gives us x squared y. In other words, loosely speaking, I know some people are not going to like it because it's not rigorous enough, but that's not a big issue. The integral symbol here and the d kind of cancel each other out. So you can safely say that this equals x squared y. Of course, we have to say this with caution because there's always a constant that you have to add at the end. But I'm going to add that on the right-hand side because I don't really need to use constants on both sides, because a constant minus a constant is another constant, so it's constant. So it doesn't matter. So don't be mad because I didn't add the constant here. But if you want, you can add c1 and then c2 and then c2 minus c1 equals c, whatever, something like that. Anyways. Okay, I talked too much, so I'm going to stop. So integrate x to the 4th power. That's going to give you x to the 5th divided by 5. And I'm going to add my constant c at the end. Okay. Now, we are solving for, our goal is to solve for y, right? So we got to be careful here. So we multiply both sides by x. We got x to the 4th power. And then we kind of separated the expression into two pieces. And then we integrated and we got this expression. Our goal was to solve for x. So what we should do is divide both sides by x squared. And remember, x does not equal 0, so this is allowed. So from here we get y equals, if you divide x to the 5th by x squared, you're going to get x to the 3rd power divided by 5, plus if you divide c by x squared, you're going to get c over x squared. And this is going to give you the function, and since we have a constant, this is it. So obviously you can replace c with anything you want, including 0. If c is equal to 0, for example, from here you're going to get y equals x cubed over 5. We can kind of go ahead and test out to make sure that our solution works. If you look at the original problem, let's go ahead and test it out. This is our original equation. And suppose y is equal to x cubed over 5. Let's go ahead and test it out. X multiplied by the derivative of x cubed over 5, which is 3x squared over 5, plus the 2 times y, which is x cubed over 5. And then here you get 3x cubed over 5 plus 2x cubed over 5, which is equal to 5x cubed over 5. And that is equal to x cubed. And yay, that satisfies our equation. But what about the c over x squared part? Okay, you want to test it in general. You can also do the following. You can just go ahead and just test out the general function x cubed over 5 plus c over x squared. Let's go ahead and test it out. X multiplied by the derivative. Now I want to write this equation in this form so that it's easier to differentiate. Let's go ahead and write the 1 over x squared as x to the power negative 2. Now I'm going to plug it into this equation to make sure that my solution in general works. The derivative of y is 3x squared over 5. Of course, I'm multiplying that by a quantity. So plus, now when you differentiate c times x to the power negative 2, negative 2 is going to be multiplied. Negative 2 is going to be multiplied by c, so it's going to give me negative 2c. I should use a b there. Negative 2c, and then it's going to be x to the power negative 3, right? That's what I should be getting from there. Great. Now plus 2 times y, of course, I'm just going to write the original expression as is, and this is going to be my expression on the left-hand side. And this is supposed to equal x cubed. Let's see if that it does. So if you distribute, you get 3x cubed over 5, and then from here, you have x times 1 over x cubed, so that's going to give you something like 1 over x squared. I can write it like that. And this expression gave me 2x cubed over 5. And when you multiply these, it's going to give you 2c x to the power negative 2, but you can write it as 1 over x squared again. And notice that these two terms are going to cancel out. Adding them up is going to give us x cubed again. So notice that these expressions always cancel out when you differentiate. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.